solve. And,
The interval of 0 to 2 pi.
oh wait, okay, so solve open like this on 0 up to 2 pi. Okay. And what was the formula? The equation.
Sine 2 theta equals cosine theta.
Sine 2 theta is equal to
Mm-hmm.
cosine 2 theta. Like that. Okay, guys, I've got to solve for theta. And he says, please find all answers caught between 0 and 360. That would satisfy that short equation. Oh wait, Michael, do I have another one after this?
Yes.
Equation, okay, let's do this one first. Guys, any ideas? Looks unusual. I do have some double angle formulas if you'd like to turn to those. For help from before the break, there's a double angle formula for here, which may mess me up, I don't know. And there's three formulas for cosine. Do you want to have an idea? And let's jump into my formula and see what that may do for me. Do nothing. Guys, does anyone recall right before the break, the sine double theta formula came out to be what? 2 sine theta, cosine theta. That's what we got? How about cosine 2 theta?
Oh, it's just cosine theta.
Which one?
Instead of cosine 2 theta.
Yeah, sine 2 theta is 2 sine theta cosine theta.
The original problem, sine 2 theta equals cosine theta.
Oh, it's cosine theta. Like that. Oh, I guess this will make it much easier then. Okay, cosine theta. The micro's in the right-hand side of that. Now, guys, what are you going to do now to solve this? Which makes it much easier. What are you going to do? And we'll solve this. No, exactly. I might say the same thing as soon. Divide both sides confessed by cosine. Do I know what theta is? At this point, no. Suppose theta is 90 degrees. What's the cosine of 90 on the unit circle? What's the cosine of pi over 2, the x-coordinate up at 90?
0.
0. You divide by 0. So since I don't know what the angle is, I'm not going to divide by cosine, because I may, one of the answers may be pi over 2. Can't do that. Another suggestion. Don't divide, but move this over and rewrite it as 2 sine theta, cosine theta, minus, when I move it over, cosine theta is equal to 0. Now they're on the same side. Now what from algebra might you want to do now? You got them together on one side. What might be wise to do now? In those two terms. Do those two terms have something in common?
Group. Factor out cosine.
Factor out, there you group. Factor out cosine. I heard it. They got a cosine. And you're left with 2 sine theta minus 1 is equal to 0. Did a little factoring. Took out cosine. And then from algebra, it's now time to set each one of these factors equal to 0. Interesting. And this one equal to 0. And solve. That's what you do in algebra. Set each factor equal to 0. Guys, now can anyone tell me where have you seen cosine, the x-coordinate, equal to a 0 on the unit circle? What spots, angles? And they must fall between 0 and 360, which is one complete revolution of the unit circle. Can anyone tell me one spot for sure that if you take cosine, the x-coordinate, it's guaranteed to be a 0? It is pi over 2, isn't it? Is there another spot besides pi over 2? 3 pi over 2. And those are the two from that side. The other side is to solve it. I got to move the 1 over. Let's do a little work here. Divide by 2. And sine theta is equal to 1/2. Now, I got to find, guys, on your test, on your final exam, I got to give you things you recognize. I can't give you something crazy where you have to use a calculator. Does anyone recognize where you've seen sine, the y coordinate, equal to a 1/2? Help me out.
5 or 6.
5 or 6. 30 degrees. And I think there's another spot.
5 or 6.
5 or 6. Therefore, Michael, my answers are, for this equation you give me up here, and I don't care what order you place these guys, you got pi over 2, 3 pi over 2, pi over 6, 5 pi over 6. And you are finished. Done. Michael, is there another equation there to solve? Tell me the next one, please.
Cosine 2 theta
Cosine 2 theta.
plus 5 cosine theta
Wow. Okay,
plus 3.
plus 3 equal to 0. And on the same interval from 0 to 2 pi. Guys, this is asking, do you know your formulas? Now, that cosine double theta, right before the break, we had 3 versions of it, I think. I think we did. Yeah, we did. Right? Cosine 2 theta, I think we did. Can anyone tell me, which of the 3 versions, reflecting back before the break, might be most convenient to use on this particular problem? One version, I think, was cosine squared minus sine squared. That would bring a sine in. There's no sine up here on this problem. The other one, I think, was 2 cosine squared minus 1. There's another version, which looks like it might be nice to use it here for a formula. 2 cosine squared theta minus 1. And then, of course, he tells me I still have this plus 5 cosine theta plus 3 0, 0. And these everything's in terms of cosine. Guys, this is going to be a nice little quadratic. Let's rewrite as 2 cosine squared theta, or rearrange to make it look like a quadratic. 5 cosine theta. My numbers, -1 plus 3 gives me a plus 2. Look at that. If you wish, to look more like a quadratic, you may say, Professor, could I even do this like we did back on something else? Let u be something? There you go. Might even look better like this. Let u be cosine theta. And rewrite this as 2u squared plus 5u plus 2. Look at that. Now you're back in middle school. Factor. I hope it factors. I do not want to use the quadratic formula. So guys, here goes 2u, I think it's going to be a plus 2 here. I'll check my factor now. Plus 1. That is. Split these up. Guys, real quickly. You'll end up with u is equal to a -1/2. We've done this so many times. And when I solve this, we end up with u is equal to a -2. Of course, u was representing cosine theta, so I'm not quite finished. Let's go back and say, hold on. This says cosine theta is equal to a -1/2. And this one says cosine theta is equal to a -2. Now, can anyone tell me from the unit circle, where have you seen on the unit circle cosine x, the x coordinate, equal to a -1/2? I hear 2 pi over 3. Hang on now. And 4 pi over 3. Got a unit circle. Guys agree? Over here, you're saying, okay, where have I seen cosine x coordinate equal to a -2? Never. Cosine the max is 1. The middle is -1. This is out. Makes no sense. Final answer, Michael? All I can list here is 2 pi over 3 and 4 pi over 3. And we're finished. Done. Okay, Michael, is that the solving equations?
Yes.
Oh, wow, this is going well then. Okay, what's the last one? Am I near the last part of this?
Find the exact value.
Oh, hang on now. Find the exact value, to what that expression looks like.
Cosine
Okay?
2 inverse sine
2 inverse sine
3/5.
3/5. Guys, on this one, I'm gonna play around with it. Michael, please tell me, is this the last thing we need to do on this handout?
Yes.
Woo! Okay. Now, I need some input from you. He says that's the last thing we need to worry about. Cosine 2 inverse sine 3/5. Now, first, what does that remind you of? That you're gonna jump out and try to use. The way it looks. Based on what you've seen today. I'm gonna turn to for help. Shame on you. Where are you gonna turn to for help? And we're doing all formulas tonight. This is in essence a cosine double. See it too, here double. And this right here represents some angle. So cosine double theta. And I need then the cosine double theta formula. Roberto, is that the one that has 3 versions? I said, we don't have enough to worry about. Remind me, cosine double theta, one version is cosine squared minus sine squared. Is that true?
Yeah.
Okay. Just a mathematician. Minus sine squared. Just in case, who knows, after I get back to my black problem there, it may be wise to use another version. I think it was 1 minus 2 sine squared. Do not let me copy these down wrong. Jeez. And the other version I think was, help me out here, 2 cosine squared minus 1. Guys, check and make sure I have these copied down correctly. Are those the ones? Whew. Okay, here goes. Cosine double theta, that's what that says up there. Cosine double theta. So which one of these red formulas for cosine double theta am I going to use? Well, I got to do some thinking about it.
1 minus 2 sine squared theta.
Well, since they give me cosine double theta, and I do see sine right here, this inverse sine 3/5, give me a hint on which of the 3 I may want to try. Guys, first we're going to do this. Can anyone translate for me what that means right there? Just that part. I'm not going to solve it. Just tell me, what does it mean? Inverse sine 3/5. What does that mean? Translate for me. What does it mean? Inverse sine 3/5.
Instead of pi over 12.
Now, here's something.
Instead of pi over 12.
Well, I don't think it's on the, hold on here. I don't think 3/5 is on the unit circle. I don't think you can find 3/5 on the unit circle. So I can't go directly to the unit circle. But can you at least tell me what it means, just in a statement? We're trying to find the number. What does inverse sine 3/5 mean?
Sine theta 3/5.
I love it. It means there's an angle out there, I have no idea what it is, but there's an angle out there whose sine, Brianna, that's exactly what it means. The sine is 3/5. Okay? And there has to be find cosine double theta, and you guys are saying now, since that sine's in there for sure, Professor, it might be wise of those 3 versions to try that one. To get the answer. I'm gonna try it here, guys. So on the side here, this should be equal to, okay, 1 subtract 2 sine squared theta, I'm using that version. And it says sine squared, it looks like sine is 3/5. Okay, and that's being squared. Step back and look at it, see if you guys agree. You guys agree? All that put in correctly? I think. Let's finish it up. This is 1 subtract 2 times 9 over 25. Jeez. 1 subtract 18 over 25. common denominator 25, you can do the math, that guys, I think it's 7/25. Yes or no? Lord, there's the final answer. Now see, so it looks already like, I don't know, it's a Monday or what, students are looking. Woo, Mr. Park, do me one more favor here. Would you find what the calculator shows for inverse sine 3/5? I'm just doing a little check. What angle, what is the size of the angle? The calculator will actually show the angle.
31.
Close to 31 degrees. Beautiful. Now it says double it. If I double it, it becomes 62. Now find the cosine of 62 degrees.
0.47.
0.47?
Yeah.
And we got 7/25. What's 7/25?
0.28.
Close enough? So you said 0.48? Come
No.
on, Mr. Perkins.
0.28.
2.8 here? Did you say
Isn't it?
4? What's going on here? Are you telling me we missed the problem? Don't scare me. Cosine of 62 degrees.
Oh, I made a mistake. Sorry.
What's the cosine of 62 degrees?
So it should be cosine of 73.
Tell me again?
It should be cosine of 73 degrees.
So the inverse, was that 31 degrees?
No, that's 37.
37?
Yeah.
Scare me there. Now if I double that, which says do, that's what, 74? Now what's the cosine of 74?
0.28.
0.28. We got this. We got 7/25. What's 7 divided by 25?
0.28.
0.28.
Yeah.
Okay. Right? All this coming together for us? Okay. Michael, I've been on you so much tonight. Is that done?
Yes.
Woo! Now, here we go. I'll show you something that you might, if I do not ask you on the final exam to be specific and use formulas. When I say use formulas, what's the formulas? If I do not ask for formulas, and to close this down, and you have that same problem that Parks has helped us out with, this one, we used a formula. Say, Professor, could I do this visually? I'm a visual type person, Professor. I'd like to know visually what on earth did we just do? Watch carefully. What we did was, we said sine theta is 3/5. And theta is located in quadrant 1. You guys can figure that out on your own. Quadrant 1. So I'm in quadrant 1, and sine of theta is 3/5. Watch what's going to happen here, guys. Same problem. I'm in quadrant 1. Let's set this up with theta. And this is theta right in the corner. I'm going to drop a perpendicular, which is going to be line chapter 7 here. Drop a perpendicular, which we're all accustomed to, most of us I think we are. Drop a perpendicular here. Form a small right triangle. Has theta in it. And all I know about theta is sine is 3/5. Anyone tell me anything to label on that right triangle if I realize sine theta is 3/5? What could I label on the triangle to show that? I've got 3 sides, hypotenuse and the other 2 sides. Does anyone have an idea of what could I label any of those 3 sides with, knowing that sine theta is 3/5? Where sine is y, if you want to consider the unit circle. If you want to consider a circle around this, this is acting like 1. If you want to consider the unit circle. So I can put a 1 here if you wish. Now where's the 3/5 go? Where sine is 3/5. Is sine y? Is this representing y? That's 3/5. Does that make sense? For an illustration of what's going on here, it's just about an illustration. Okay, I'm thinking about the unit circle here. And if you want to find that missing side down there, c squared is equal to a squared plus b squared, and I'll do it fairly quickly. Someone may know what it is. Does anyone know what it is if you use c squared is equal to a squared plus b squared to try to find it? I think it is. Is it 4/5? There's the triangle. There's a picture of, in essence, what was going on with this. Now, they asked to find double that angle. I'm not going to double it here on this one, we're using illustration. We said, well, to find it, Professor, use this formula. Find cosine squared theta. By the way, guys, with this illustration, what is cosine, which is the x? What is cosine on this? If I accept cosine as x, is that 4/5? So cosine squared is 4/5. If I want to use that version, subtract. Sine squared, sine is y, well, that's the 3/5. Put that in, and guys, I think we'll end up with 16 subtract 9, which is 7 over 25. Please tell me, is that the same answer we had earlier that Park checked for us, me using this? I mean, I could go to an illustration and in my mind set up what it means by an illustration and then find the answer also, which might be a little bit quicker. Does all that make sense, guys? That's the way I want to close that down. Yes, no? Woo, okay. Now, Michael, class, been waiting for this. This handout right here will, for the most part, what is today, Monday? We have class on Wednesday, don't we? Of course we do. This is a continuation, and then it starts chapter 7. And when I get to chapter 7, and you see those definitions that they changed the definitions wrong. They changed the definition when you get this handout to sine is length of opposite over length of hypotenuse. Now they're going back to middle school, which will make chapter 7 much easier for us. So you guys can get this passed out. And Anna, help me out. Pass it out. Yeah. Mark on the creek.
Hmm?
Okay.
Yeah, I'm good.
I'm good.
Yeah.
I have some right here. Thank you. Okay, guys. I'm looking at my clock here. Please tell me, does that mean we have only like 25 minutes? And I've also got passed out the review for the final. Okay, Michael, you got this? And I think it says a continuation. At the top there of the handout, guys, we'll get this done for sure. It says to establish an identity formula. Here we go. Part 1. Michael, would you read that first one which says to establish, not solve, establish?
Cotangent theta.
Cotangent?
Cotangent theta
Okay.
minus tan theta
Okay.
over cotangent theta plus tan theta.
All like this.
Mhm.
Cotangent theta plus
Plus tan theta.
tan theta. And what's that supposed to be equivalent to?
Cosine 2 theta.
Oh, God. Hey guys, we're not trying to solve this. It says to establish if that statement is true. Here we go. I don't think it's gonna be too hard. You're supposed to stick to one side and do the best you can what you have to work with, knowledge that you have to work with, and change and make the two sides the same. Now, I would work on the left-hand side. Now, can anyone look at the left-hand side and tell me something I can do on the left-hand side based on things you know that might eventually lead me to my result? Okay, stay on the left-hand side. Guys, anything on the left-hand side you see that may help?
Cotan theta,
Cotan, I could change cotan, it will help me into,
1/10.
I could, in fact, I could do better than that. Because I think they want me to find cosine double theta, and I think cosine double theta had 3 versions, and none of those 3 versions had a tan.
Cosine over sine.
There you go. So if you wanna call it step 1, guys, go for it. I'm gonna write this as cosine over sine. Nice. Tangent? I think it's sine over cosine. Making replacements that we know what they are. Now, my denominator that he gave me, I see another cotangent, cosine over sine. Interesting. Let's hope we have this thing copied down correctly. Plus, on the bottom there, tan, another sine over cosine. That's getting a little messy, but you get partial credit for that much. And guys, keep in mind, my aim is to change this into one of the formulas for cosine double theta. Now, what would you tell me now, guys, based on step 1, what can I do in step 2? Try to clean it up. What do you suggest? Anyone? Oh my goodness.
Cosinus 2 delta is like cosinus squared minus c squared.
Oh, help me up here. I think I'm here. Suppose I put those 2 together with a common denominator. I think it's from here. Can anyone tell me what the top part would look like put together with a common denominator? By the way, that common denominator up there would be this, if I need it, sine theta cosine theta. So guys, I'm trying to put all the top together with that denominator. If I do, my first fraction has sine, it's missing cosine, I'll put that in. Cosine theta, cosine theta. Second fraction on top is missing sine, I'll put it in. Sine theta, and this is algebra. So I'm putting those 2 fractions together. Take a close look, on top there you have cosine squared theta minus sine squared theta. Still over, now I've got to do the bottom part of what he gave me. Now, guys, if we do this, do the green, I gotta jump down and say, wait, Professor, we gotta clean this green one up with the same idea, another common denominator, which is the same down there. Sine theta, cosine theta. This will be the bottom part. This is missing cosine, put it in. And here. Cosine, put a sine in. Over here on this one, all with the common denominator. Guys, down on the bottom there, I got cosine squared, I think, if I have no mistake, plus sine squared. Do we agree? Let's put things together. Please, class, because I'm around time here. Do we all see that if you look at it closely, will these 2 denominators cancel out? On top, I'm left with cosine squared minus sine squared. Was that one of the formulas listed before the break for cosine double theta? But I also have left in the green cosine squared plus sine squared. What's that equal to? 1. So that directly will give me cosine squared minus sine squared all together. And as soon as I see that, I know now you have matched it up with one of the formulas for cosine double theta. You now have the two sides equivalent. Is that making sense? The way we approached it. Beautiful problem. Different. Okay, Michael, what else is there? I have to watch my time here closely.
Cosecant.
Okay, now what they asked me to do here? Establish
Establish.
again? Another establish?
Mhm.
Okay, here we go. I can read that to me, please. Establish what?
2 theta,
Two theta, sine two theta or
cosecant 2 theta
cosecant? Two theta,
equals 1/2 secant theta
whoa, Okay.
minus cosecant theta.
times cosecant. And they're saying, show the two sides are equivalent. Not try to solve. What a night this has been. Okay, I want to tell me which of the two sides might you as a student want to work on. Which one looks like it might be a little bit more, the way it's presented to you, more likely to lead me where I want to go, or at least I can do something. Which side? Left-hand side or right-hand side? Right-hand side. I would. Why? Because we write this as 1/2. And secant theta, if you wish, can be expressed as 1 over cosine. If that will help. And cosecant can be expressed as 1 over sine. So Michael, we have all this copied down correctly, don't we? Is that true? Everything's copied down correctly? Okay. Now I put my replacements in. Now at this point, guys, this merely means on top 1 times 1 times 1 is 1 on those fractions. 2 times cosine times sine could be expressed like this. That's no problem. That's where I am right now. Now please, I know I threw a lot at you tonight. Is this right here a formula? From before the break? What is 2 sine theta cosine theta itself equal to? This part right here. If you turn around a little bit,
Sine 2 theta.
that's sine 2 theta. So I can write this as 1 over sine 2 theta. That's a formula down there. And if I say 1 over sine, what's 1 over sine always equivalent to? The reciprocal cosecant. So this merely can be written as cosecant 2 theta, and that's what they wanted us to show. And there it is, established. Oh, we're gonna have fun on the final exam. We're gonna have fun. Should I bring chocolates? Usually I do. I should bring chocolate or something as up. You guys have a little energy. So you're gonna be drained. Once this final, oh my goodness, we'll be chocolates. Okay, guys, Michael, are those the only 2 established ones?
Yes.
Woo! Now, is the next part to close this down called half angle formulas, as if we don't have enough formulas. Okay, part 2. Last set of formulas you're responsible for. Half angle formulas. Michael, I think I just listed what they look like. I'm not gonna show you where these came from. I'm not gonna derive these for you. Did I start out with sine half theta?
Yes.
So sine of half, not double, half of theta. Michael, what was the formula?
Plus or minus
Plus minus,
square root 1 minus cosine theta
1 minus cosine theta,
over 2.
all over 2. I will not show you where it came from. And the other one? I think it's a cosine, wasn't it?
Cosine 1/2 theta.
1/2 theta, half angle formula is plus minus large square root, what's underneath this one?
1 plus cosine theta.
There you go. All over 2. Now, I think that's all I gave you. remember in your math 8 or math 7, did you guys ever have to use a half angle formula? What do you recall?
Yep, all the time.
Okay. There they are. I didn't show you where they came from, but there they are. Now, Michael, tell me please, what was I asking you guys to try to use to apply this?
Find the exact value,
Of what now?
cosine pi over 12.
There you go. Now, I got a little short story about this one. Cosine of pi to 12. On my final exam, one semester, I asked students to find the value of cosine pi over 12. Did we find pi, did we deal with pi over 12 before the break? I think pi over 12, if you want to convert it, is 15 degrees. So I said, just find cosine pi over 12, that's one of the questions for the final exam. So I took the test also, I had my answers. So I started comparing papers, my test to my students' test. So what I did, I wrote this as cosine of, here goes that now, just watch. I wrote this one as this, that's why I